Hey everybody, this is Larry. This is day 26 of the February Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. 72 edit distance. Yeah, there's gonna be a contest later today, so probably gonna grab some food before then. But yeah, hope everyone's having a good weekend. I've been doing physical therapy, so I'm just kind of tired. I feel like I've been just complaining about tired. I need to sleep more. Anyway, hey everybody. Yeah, 72 edit distance. So I don't know what to say about this one. This is literally a very common textbook problem. I was going to just write edit distance, which is the name of the title. So I don't really want to talk too much about it today. I'm just lazy. I'm not gonna lie. I mean, because this is a like I said, literally a textbook problem, meaning that you find in a textbook, not to like this is one of the first versions of dynamic or not, but like one of the first problems that you might encounter in dynamic programming. Maybe the second one, maybe the third one, something like that. But so, yeah, so very early on is my point. So definitely, yeah, I don't think I am going to be like, sorry. Wait, I also just went for a couple of miles, so I'm just like really dehydrated. But yeah, I don't think I have anything that hasn't already been said about this one. I think the cool thing about this is that the way that I always thought about the cool thing about this is that there is a sort of a symmetry that you can kind of think about to exploit, right? Because I think like, especially with your beginner to dynamic programming, I remember like just finding how beautiful it is mathematically, I guess, because I am a nerd and that's what I find beautiful apparently. But just like this idea that you can take stuff from the middle, but actually it doesn't really matter, and you just try to simplify things such that you only care about the suffix, right? And then everything that you've seen before, it doesn't matter. That kind of thing. Let me take a look at the constraints. Okay, constraints 500, which should be okay, n square. I only wrote a little bit because Leetcode is kind of weird, so we'll see. But yeah, but basically the idea is that okay, maybe min distance. The way that I explained the elementary dynamic program problem is that technically you only care about the suffix for this one, right? And because of a suffix, you can actually represent, you can actually represent suffixes as, because they really all the suffixes are of a certain length is going to be the same, right? Because that's the definition of, a suffix and stuff like this, so you don't have to put in the entire string. So I guess technically speaking, maybe you could have. I don't know how I feel about it, but yeah, but basically that's generally the idea, right? Is that yeah, is that you take care of the suffix. So then here you have maybe, I don't know, index 1, index 2 mapping to word 1, word 2. Maybe I would have n1 is equal to length of word 1, and n2 is equal to length of word 2, right? And then yeah. And then basically the thing is that, okay, if index 1 is equal to n1, then you have the rest of index 2 to kind of just to think about, right? So that means that, and you can't really do anything other than to delete them. So that's basically what we're going to do, right? So that is just, what is that? So we return n2 minus index 2. Is that right? Yeah, I mean, I'm just double checking because it's very easy to do off by ones on things like this. At least I feel like I make a lot of off by ones as a result. So yeah. Okay. So then now the second part then is just for symmetry reasons. Hopefully this one makes sense as well. And then now, and here maybe I'll add a notation. We move the rest of the characters because that's the only way to match a thing. So okay, so now how do we match them, right? Actually, I think I confused these forms a little bit. Or maybe not, but I think about it already in a different way, which is kind of because the idea about it, yeah, I think I skipped this a little bit, and that's my fault. And what I wanted to say was that the reason why there is this symmetry instead is that instead of thinking about necessarily inserting a character and deleting it, because right now all our operations are operating on word one, right? We can add a character, delete a character, and replace a character, or crossing one. Otherwise, you have, I forget what there are not like two computer scientists or in a general form, but I forget all these names now. But yeah, basically you have insert, delete, and replace, right? But what you can also do, actually, it turns out, is that what is inserting a character, right? So basically, let's say horse and rose. If we insert this character, oh wait, well, actually, that's not quite right. All right, let me, this is not one with a character. My fault. Sorry, hang on. I think yeah. Let's just say, let's just do it. I don't need to use examples. Let's just say A, B, B, C, C, right? Something like this. Yeah, in a greedy way, we can say the first one here. And then here, instead of, there are two ways to say this. Like I said, one way to say it is that we insert A into the word one, but that is actually equivalent to deleting a character from word two, or the first character specifically, right? So that's basically kind of the symmetry that I kind of appreciate, and with that, it makes it a lot easier to kind of. The math is going to be the same either way, but at least for me, it's always about the visualization and thinking about a problem, and having this symmetry allow me to, the visualization allowed me to understand the problem better, and when I understand the problem, then it allows me to write correct code easier, right? And what I mean by that is that if you're not really careful about it, it's very easy to have off by ones, because you just have a general idea, but your bounds aren't concise. You're like, maybe here I use inclusive, here I use exclusive bounds, and then you get all mixed up, right? So yeah, so that's basically kind of what I wanted to talk about with respect to that. Okay, cool. So yeah, so then now we can now get to the point, which is that we can remove. So okay, so if word one of index one is equal to word two of index two, right? Then we can let's just say best is equal to some infinity number, right? Let's just actually make this infinity, right? And then here we can say that yeah, then best is equal to min of best, min distance, index plus one, or index one plus one, index two plus one, right? And here we're just saying, okay, the numbers match, or the characters match, we can just shift to check the next one. That's basically what this is saying. We can also, like we said, we can insert a character that matches the first character of word two, which is, and what I said before, now you could delete a character from word two, or the first character. So then now this is just index one plus, no, yeah, you don't move index one, but you move index one plus one. And here there's a cost of one because it costs one operation, right? And then now the other thing you can do is just delete the first character of index one. So you have something like, I don't know why I'm having so much trouble typing, but yeah, so something like this, right? Oops. And you start at the beginning. I know that I didn't do the memoization yet, so hang on. Did I mess up something? Wow, this isn't even close. Oh, I'm missing one operation, because then here this is insertion, this is deletion, and then we can also replace. What does replace mean, right? Replace means that we can go ahead right? So replace means that we can do index plus 1, index 2 plus 1, plus 1. Because basically you're replacing the first character in word 1 with the first character in word 2, and then they match after that operation, and you can shift to the next character. Okay, so let's run it again. Okay, looks good. Time is really slow even for just 5 and 3. So of course, the reason is because we need memoization, right? You probably knew this. This is a dynamic programming day. Maybe we have a dynamic programming thing next couple of things, but yeah. So basically the first thing we do is we look at, well, how much space do we need, right? Index 1 goes to 0 to n1, index 2 goes to 0 to n2, so number of possible inputs is equal to n1 times n2. So that's the space we need, because each input takes all of one space, because we're only storing one number for each space, so that's going to be all of 1. So okay, so let's allocate the space. Yeah. I always, the order is always hard for me in Python. I always have to think about it a little bit. I think technically I don't need this, but I always like to do it just to be a little bit safe, right? And then now we can just we could check the cache. If the cache have these indexes, and then we can just return the cache. Otherwise, we should save it next time after we do the calculation. Right. Looks okay, and you can see that the runtime improved drastically. So let's give it a quick submit, and yay, we got it on the first go, 1062 streak. Yeah, and the only thing that add here is that each input takes how many times? Well, all of 1 time, because it really just does 4 lookups. So yeah, so that means that total. It just looks like total time is equal to all of n1 times n2, or n times m maybe is a little bit cleaner, I don't know. And total space is also over n1 times n2. Yeah. It turns out you can actually optimize this a little bit. One is by going bottoms up, first of all, and then after you go bottoms up, you actually are able to do a space optimization. If you want to learn more about that, I have a video that kind of goes over that progression for a similar problem, I think. I don't remember anymore. But yeah, definitely check that out. I'll put it in the comments. So yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, do good mental health. If you're in the contest later, good luck. See you later. Bye-bye.